This meeting is being recorded.
Alright, hello and greetings. Today I would like to present my research entitled LULC Pattern Analysis in Sabah via CA-Markov algorithm. So this is the content for today for my research presentations, introductions to LULC and CA-Markov algorithm, methodologies for LULC pattern determination, and also the result and discussion. So introductions to LULC and also CA-Markov, okay, definitions and importance of LULC, land use land cover changes, or referred to as LULC, is actually can be determined as the characteristic of land based on its use and physical cover. Understanding the LULC is very important for sustainable resources management and as well as environmental planning. So the current trends in LULC's research, which is recent studies in LULC focus on the impacts of urbanization, climate change, and also agricultural practices. So advanced technologies such as remote sensing are increasingly utilized to monitor and also analyze the land cover changes. So the CA-Markov algorithm is referring to the algorithm basics and also the mechanism and also application of CA-Markov in LULC studies. So the CA-Markov Markov algorithms integrate with the cellular automata and also Markov chains to simulate the land cover transitions. These algorithms effectively predicts the future land use pattern based on the historical data and also the spatial interactions. And the applications between LCA in LULC study, CA-Markov has been employed in various studies to project urban expansion, assesses the environmental impact, and also inform the policy decision. Its versatility makes it essential tools for researchers and planners in the fields of land management. So the methodology used for LULC pattern determination, the satellite image sources, satellite image serve as a primary data, sources of the land use land cover changes, LULC studies, providing high resolution image from various platforms such as Landsat, Sentinels, and also commercials provider. And the data pre-processing technique is very important to enhance the quality of the satellite imagery, including the steps like atmospheric correction, geometric corrections, and also normalizations to ensure the accuracy of the LULC classification result. So the implementations of CA-Markov are dividing into two, which is model calibrations and validations, and as well as the scenario analysis and the future projection. In model calibrations and validations, CA-Markov models involved with adjusting parameters using historical LULC dataset to improve predictive accuracy, followed by the validation against knowing the datasets to assess the model reliability. While scenarios of analysis and future projections using CA-Markov to enable explorations of various future land use scenario, facilitating strategic plannings and also policy formulation based on the projected changes in the LULC pattern. So the result and also the discussion is LULC change pattern in Sabah. Analysis of historical data, which is the historical data analysis review trend and the shift of land use land cover LULC over a specific period, highlighting the drivers behind these changes and then their correlations with the socioeconomic factor. So special distributions of LULC change. This section examines the geographical spreads of LULC changes, employing GIS tools to visualize the patterns and also to identify the hotspots of transformations across Sabah, which aid to understandings in regional dynamics. So the implications of this finding, okay, environmental and ecological impact. So the findings underline significant environmental consequences such as habitat loss and also altered ecosystem, emphasizing the needs for ecological assessment to inform the sustainable practices. And the next one is policy recommendations for land management. Based on the research outcome, this section suggests actionable policies frameworks aims to improve land management strategies, ensuring their sustainability and also conservations in light of ongoing LULC changes. And that's all from me today for the presentation. Thank you.